Hello, this is my next video in a series I'm calling Transformations of Random Variables. And we're going to take a uniform 0 to 2 random variable and transform it with this transformation. We want to find the density of y. And so we'll just start right in, and f of x is 1/2 over the range of 0 to 2. That's what a uniform distribution is. And we want to transform it to y. And that looks like this distribution. Now, why this is unique, and I actually saw this video online, and so I couldn't find the video again, so I'm not for sure who to give credit here, but I really like it because it's a video where we're transforming a random variable that is not one-to-one, right? It's a function, but it's not a one-to-one function. And over different regions, you sum a different number of transformations. And I'll show you what I mean by that in a second. So the function looks like this, and this value is at 4. And so if we pick a y value that's in here, then we need to find the probability of this x happening and the probability of this x happening. Where if we're, in a value here, in this range, then we only need to know the probability of this x happening because it's not over here. Y is above 4, I need 2 probabilities. And if below 4, I need 1 probability. Anyway, so I just thought it was pretty neat, and it helped illustrates the idea of breaking it into regions. And then when you go to find the density of y, you have to sum over each of these regions, but you only use the regions that y is in. Okay, so here we're going to partition into 3 regions from 0 to less than 1, 1 to 2, and then 1. Now this region here has probability of 0 happening. Probability that x is equal to 1 is 0. So wherever this gets transformed in our y range, it contributes probability 0. So we can essentially ignore it. And as long as there's only a finitely many values that have probability 0, then you can ignore them. So this is our range, and we need the region. So this is, now here we need a back solve for this. So that means take the square root of both sides, so we get plus or minus square root of y times this, and then you do your solve and you get this. You get x is equal to plus or minus square root of y, 1 plus or minus square root of y. So there's 4 possible values here. But we can only, so we need to figure out which ones. And so of all the combinations, this one maps to 0 to 1. So this is over region 1. And then this one maps on region 2. And so that's just trial and error basically. So you have to figure out which one maps to do that. And then we take the derivative of both of these, and we get this. And notice that there's a sign change here. The 1 and minus 1 will go away when we take these, the absolute value of them. So over region 1, we take f of x, plug in what we have back solved for, which is this, plug it into the density. But it's 1/2, so there's really nowhere to plug it in. And then take it times the absolute value of the Jacobian, which is this. And then we do that for region 2. We plug in this x to the density of x, which is just 1/2, so we get 1/2. And then take it times the Jacobian, which is this, and we get that. Notice the 2 here becomes a 4 because of the 1/2 in this density. So now when when y is between 0 and 4, it's this value, and then when y is 4 or more, we have to add both of those probabilities. And so this is it. This is the density. That's the final answer. Now, to see what the value looks like, the density looks like, it is this. So this is y, and this is f of y. And when we're below 4, that's an open circle. It looks like this, and then from 4 on, you get this. And so, and technically these go forever, but you have to restrict them to their right regions, or the correct regions. So that's all I have for today. Hopefully you enjoyed it. If you did, please like it and subscribe so you don't miss the next one. Thanks. Bye.